Hello everyone, welcome to today's Novedge webinar, Mastering Large-Scale Environments with Forest Pack. Learn how to manage scenes with hundreds of thousands of objects, each with millions of polygons, while a point cloud display mode and several optimization features keep the viewports fast. You're going to love Forest Pack 6. And let me tell you a little bit about today's presenter, Paul Roberts. Paul joined iToo Software in 2013 as training manager and is currently producing documentation and tutorials. He has graduated with degrees in both animation and architecture and has been working with 3ds Max for over a decade as a 3D designer and trainer for the games, product design, and visualization industries. Excellent, just the right person for us. And now let me tell you a little bit about Novedge. Novedge is one of the largest online stores for design software, and our assortment of software solutions is huge. So that, if you need Forest Pack, we have it. If you need 3ds Max, we have it. You name it, we carry it. And for more daily software news and limited time promotion, you can always find us on Facebook, Google+, Twitter, Instagram. And for more daily software, that's it for the daily software news. And our upcoming webinars will be on Vectorworks 2019. And this session will be recorded, so you can watch it again on our YouTube or Vimeo channels. And now I will share Paul's screens. Just give him a few seconds to make the transition, and then it's all yours.
Good to go?
Good to go.
Excellent.
Wait, Paul, we're not seeing your screen yet. Okay, here it is.
See it? Yeah. Okay. Hello, everyone. I'm from iToo Software. Thank you for the introduction. Little bit of background about iToo, just quickly. They're based in the south of Spain. They've been developing plugins for 3D Studio Max, in fact, Forest Pack, since the late 90s. So this is a plugin that's been around for quite a while. And those of you who know Forest Pack will see that that's reflected, in the number of features that are there. It's been built on for a number of years. We also are the developers of RailClone. RailClone is a parametric modeling tool for 3D Studio Max that has the same instancing power as Forest Pack. So not only a modeling tool, but also able to create millions of polygons in a scene. I'm going to show a little bit of RailClone today too, but we have a much more in-depth webinar planned for later in this season. What I'm actually going to do today is to look at Forest Pack using a scene by Studio Niscota, or as they were called at the time. They're now called Poly Machine. And it's this scene on the left here, this enormous lakeside scene, which is several kilometers across and contains hundreds of trees, thousands of blades of grass, and all sorts of other good bits and pieces. So I'm going to use that as a kind of excuse to talk about some of the features of Forest Pack, some old, some new. There is a second project by Bertrand Benoit, which is for RailClone, but we probably won't get to that because I know that I talk too much. And so we'll probably save that for the second webinar. So the interesting thing about Studio Niscota is that all of their work is pretty much as it comes straight out of the render. They are a no-post company. Again, they're called Poly Machine now. I apologize for the update, the lack of update there. So they are a no post-production company. They try and do as much as possible straight out of the frame buffer. A little bit of curves maybe, but not much else. And here you can see the clay render of that previous scene. So you can see it's all 3D geometry. That's fantastic for us because we're interested in being able to scatter and create scenes with tons and tons of 3D geometry. So this works as a great demonstration. The other thing about Niscota is they're particularly interested in creating assets that can be reused time and time again. So if they have to create something for a scene, they'll create it at a high enough fidelity that it's good to be used in the foreground of some future scene, even if it's only used in the background in this scene. So in that scene, for example, in the foreground was this quite detailed boat. So it made sense that they produced it with quite a bit of care. Also in the scene, there's an axe. The axe was custom modeled for this scene, and they put a lot of effort into the creation of this axe. What's interesting when we look back at the scene is, where is that axe? Now that was quite a detailed axe, but we can't see it. There it is, just there, tucked away. And if we zoom in, we can just about see that axe. Now that might seem like overkill, but the point is they can use this axe in future scenes, and it could be a foreground object. And the beauty of using Forest Pack and RailClone is it doesn't really matter if they're scattering high poly objects, because Forest Pack makes that possible. So let's have a quick look at how this scene's set up. First of all, an important thing about foreground poly geometry for the terrain is that you don't really need to overkill it on using customized landscape plugins or separate tools. Often the best way to create your foreground geometry is just simple poly modeling with a turbo smooth modifier on top to create some nice detail. It makes it very easy to control. You've got generally a low poly cage to control everything, and more importantly, the kind of geometry that comes out of this works very well with Forest Pack. Sometimes if you're using geometry that's come in from more of a sort of displacement style of terrain creation, what you'll find is you get small spikes, very irregular, uneven geometry from one poly to the next, which can cause problems when scattering large areas of grass, for example, using patches, because these patches will end up on end or something like that, and they won't look like the final render. So simple foreground modeling is often best done like this. If you are using that kind of displaced geometry, or geometry that's been produced by photo scanning the terrain, for example, then there are some tips to help to make this geometry more manageable, make it produce fewer trees in the scenes. And one of the ways is to use discontiguous landscapes. So if you are seeing a scene that goes back some distance like this one, there's no need for that terrain to be continuous from right in front of the camera to the very, very far background. As you can see here, the area in front of the camera is just a small patch. And then we have 3 or 4 other pieces in the distance to scatter trees. And then way in the background, a sort of mountainous terrain just to fill in. If you're doing the whole terrain with that kind of mountainous terrain, then another way to reduce the poly count is actually to make it discontiguous by deleting polys that face away from the camera. So the quick tip for doing this in a way that's non-destructive, if you just select your terrain and you go into poly mode and turn on ignore backfacing, you can select just in the cameras, from the camera's perspective, the entire scene to select all of the polygons that face towards you. If you then invert that selection using Control and I, you've got all the polygons that are facing away from you. And then you can just pass these up the modifier stack. Don't just delete them, because otherwise if you move the camera, you're in trouble, to a delete mesh modifier, and it will just delete all the polygons that the camera can't see. So from the camera's perspective, this scene is going to look exactly the same, but we've now got half the number of objects being scattered. So that's a nice tip for just optimizing scenes. And the good thing is, doing it this way with the modifier, you haven't done any permanent damage. So I mentioned we're going to start with RailClone. And in this scene, when Polymachine sent this to me, there was a power line in the background. And just like with the axe, it struck me when I looked at this model for the first time that it was incredibly highly detailed. Every rivet has been modeled, every joint. It was several thousand polygons per pylon. So what's interesting about this is the way it was created. So instead of just placing these manually, the whole thing was created as a parametric RailClone object so that it could be easily updated and moved on the landscape. And I'd like to show you very quickly the basics of RailClone using this example, and we can explore RailClone in more depth in a future webinar. First of all, let's try and spot this pylon. Going back to our axe example, it's a highly detailed object, but where is it in the scene? Well, it's difficult to see. It's there. Even if you zoom in, still difficult to see. But again, this goes back to their philosophy of throwing everything into a render. Here's how they're created. So they're created using RailClone's L1S generator. That just means it's a linear array, a one-dimensional array, and it uses a spline to define the path of the power lines. RailClone has a node-based interface to create these kinds of styles, and objects are created using these types of generators, linear and array2s. So it's a 1D array and a 2D array. They're your options. The linear array is by far the easiest to understand. You can see it's got an input for a spline, and then it's got a default start, corner, evenly, and end input into which you can plug pieces of geometry, and that's how you build the arrays up. So here, as an example, I can just put in some placeholder geometry to demonstrate. So you can see I can put geometry in the start, in the end, in the corner, that's anywhere where there's a vertex on the spline, evenly, which is regularly spaced intervals along that spline, and default geometry, which just fills in between. So using that principle, we can create the pylon. So here we have our geometry. I've got a separate pylon, and I've got a cable. If I align the cable to the pivot of the pylon, you can see that it matches perfectly so that the cables join the pylon in the correct place. And that's important later, as we'll see. Otherwise, we can run into problems with alignment. So aligning the pivots before you add geometry to RailClone is an important first step. Then we'll create a RailClone object and open our node-based style editor. Create a new linear array to create a one-dimensional array and add a spline node so we can pick the path from the scene that we're going to use. Then to bring in geometry, you use these segment nodes and you just pick them from the scene and wire them to the relevant inputs. So here I'm putting a pylon at the beginning of that spline, another one at the end. And then also if there were vertices on this spline, you could add them to the corner inputs too. You can also change the display modes, as you can see here. So you can display the full mesh, I can display them as boxes, or for speed, I can display it as a points cloud, just like Forest Pack. Now in between these pylons, we want the cables. So we'll bring in the cables as a separate segment, because it's a geometry item in the scene, and wire this to the default input, because we want it to fill in between the other segments. Now, as you can see, there's an issue. The pylon is on the ground. And the reason for that is because we need to use the pivot on the Z-axis that we set earlier. So if we change it to pivot, it will align the pivot to the spline instead of the bounding box. Do the same thing for both pieces to make sure they match perfectly. So there we go, the cables match the pylons. Now, there's also an evenly input, which is a regularly spaced interval along the spline. Now, to create the rest of the pylons, we'll plug them into there, and you control this input from the properties panel here. See, I control the distance parameter, and the distance between those pylons changes. It's not always the easiest thing to open this graph and change that. So one thing you can do in RailClone is to export any property, like this evenly distance property, and wire it to a numeric node. Any numeric node in the scene, and I'll just give it a name so we can see what it is, but any numeric node in the scene ends up in the modify panel. And that means that you can change this property without ever having to open or understand this graph. Like so. The other issue there is that, as you can see, the cables are not connected, they're getting clipped instead of scaling. So we can change the mode there to scale, and now it scales one complete cable between each one of the pylons instead of just cutting them once they reach the pylons. And the other problem is that because it uses the bounding box to determine where that cable ends, and because this pylon is wider at the bottom, if we switch it to bounding box mode, you can see this, they don't quite connect correctly. So you can see there's a gap. And that's what the padding property is for. If you select a segment, like the pylon segment here, and go to the general rollout, you'll see that there's a padding value, which allows you to overlap adjacent segments. So I can bring these values in using negative values until they overlap in the correct place. It's a little bit of trial and error, but you can do it visually. There we go, there's our completed pylon style. The nice thing now is that if I want a longer pylon, I just need to change the length of the spline. And of course, I can easily adjust the distance between those pylons using that parameter that we exported a second ago. So this becomes a very flexible style. Which is all well and good, but of course, our pylons don't follow a flat terrain, they follow an undulating terrain. And so another feature of RailClone is the ability to follow the terrain automatically by projecting the spline onto the surface. And it's very easy to do. All you need to do is pop open the style editor, bring in a new surface node, and just pick the surface from the scene, and wire the surface to the surface input. And that's more or less it. We can also play a little with the deform modes to make sure that the pylons stay upright, for example. So we can change the mode here, turn off bend because we don't want them to bend, and change the mode from adaptive to stepped, and then they'll always remain upright. Never mind the slight sort of problem with the cables, that's just a point cloud display problem. Actually, when you render it, it will look fine. And in fact, if I change this display mode to mesh mode instead, or render it, it's fine. I'm not sure if this will come through on the webinar, but it's fine. So there's your pylon complete. You can see it's following the surface, and the whole thing can be updated just by moving that spline. The projection onto the surface is fully parametric as well. So that's RailClone. As I say, we'll talk more about this in a future webinar. So let's move on to the trees, which are probably the most visible vegetation in this scene. A question we often get asked is, how many types of tree do I need to add to a Forest Pack object to disguise repetition? And my answer to that would be, well, it's not really how many different types of tree you need to add. It's to make sure that each tree is substantially different looking from the next. There is, with parametric modeling, tree modeling software, the ability, of course, to keep randomizing the trees by just changing the seed values, which will give you a different tree. But often that results in trees that are only very slightly different. Far better to use trees like this, which are very different from one another, and then you'll much more clearly, or be much less clear if there's repetition. Because Forest Pack has the ability to hide quite a lot of repetition using transform randomization. So if we take this little example here, we have one tree in this scatter, and as we can see from the render, although there's a bit of tint variation, it's very obvious that this is the same tree time and time again. But to disguise that to some extent, we can go to the transform rollout and just enable rotation randomization to change the angle, and I'm changing it from -5 to -10, and scale randomization, which I'm putting much more variety in there, from 50 to 150. And now if you pop open the render and look at the result of that, you should see that it's still the same tree, but the repetition is now much, much harder to spot. You can still see it, but with a few extra trees in there, that would become very difficult to spot the repetition. The other question we get asked is, what's the best way to actually get these trees into the scene? And you have three options here. The first option is just to have the tree in the scene as a standard mesh, saved inside that scene itself, which has certain advantages, but also disadvantages. So the big disadvantage, of course, is that it can really increase the size of your scenes, and also that it has to be loaded into memory all the time. But on the plus side, it can do things like sample animation on the fly. So there's no need to bake out or save out the animation. If you've put like a noise modifier or something and randomize the phase of that, it can sample that on the fly without needing to render out or save out to a proxy every single frame. It supports tint by element, and that's an important one. Forest Color, which comes with Forest Pack, has the ability to randomize individual bitmaps and tint individual elements inside a mesh. So that could be individual leaves on a tree, for example, could each have their own bitmap, randomized bitmap. This is supported by mesh, but not some of the other methods. And of course, you can sample procedural geometry objects like grow effects objects directly from the scene, once again, without having to convert it to an editable mesh or save it out to a proxy. So that can be a big saving too. A lot of artists will prefer to save things into proxies. There's no need to do so from a rendering perspective because Forest Pack does this on the fly automatically. But proxies have the benefit of being able to keep your file sizes very, very small. And also, they have their own modes for displaying low poly geometry in the viewports. They're also loaded dynamically when they're needed rather than loaded into memory, so that's a saving. But animations are pre-computed, so you have to save out every frame of your animation to a proxy before you use it. On the flip side, they're faster to load. And unfortunately, it only partially supports tint by element. So that feature is probably, the lack of that feature is probably the biggest reason why I personally don't use proxies. The other disadvantage not listed there is that increasingly as studios, we're working across multiple renderers, maybe V-Ray and Corona being the most obvious. And each of those demand their own proxy file. So you'll end up with 2 copies of everything. That can be sort of problematic. So in that case, I'd probably use Mesh or XREF, which is loaded into memory. So that's not so good. But it does reduce the scene file size, which is probably the biggest reason people use proxies. It does also have the ability to sample animations on the fly, and it supports tint by element. So of the 3 choices, that's generally the one I go for. In terms of getting geometry into Forest Pack, we now have a new feature in Forest Pack 6 called Update Manager. So Update Manager can be launched from the Start menu or from directly inside Forest Pack itself, and it's linked to your account. It's a new way to download the built-in libraries that come with Forest Pack. Previously, these were included in the installer, and that was limiting the amount that we could give away for free. By separating the content, the library's content from the installer, we can now create much larger libraries, and we can update them at any time without having to wait for a major release. So here we can see some libraries that need to be installed. You just select them and click install, and now they're downloaded automatically, and they'll be ready to use directly inside Forest Pack. Included in Forest Pack 6 was a whole new tree library with I think about 20 different new high quality trees that you can use. So that's pretty much as good as a commercial library coming free with Forest Pack. It's 10 new trees in multiple variations. We've also recently released new rocks library, and we can see a little preview of that here. This was only possible because of Update Manager. We released this mid-cycle, and it's something like 42 new photo scanned rocks. We can see some examples of them here. These are free, they're just included as part of Forest Pack. Also, I don't have a video for this, but also included in this update was a bunch of new leaves photo scanned as well. So like leaves that have fallen off of trees that are ready to be scattered on the ground as litterful and that kind of thing. So all you need to do is open Update Manager and they'll be available immediately. So I mentioned at the beginning that Forest Pack's been around a long time, since the late 90s, and that's resulted in a lot of features, and a lot of features mean a big UI. So we were starting to get people requesting that we simplify the UI, and the problem with that is that you can't really remove features, even if they're very old, because someone somewhere is invariably using them. The situation we've ended up with is that our UI, if we stretch it all the way out, is big. It's really, really, really big. It just goes on and on and on. And what we need is a way to make this more manageable, but without removing anything. And the way that we've done that is to give you the option to hide the rollouts you don't need. So, for example, I can hide all these rollouts that I don't need, and now I have a really streamlined version of Forest Pack with just the core features. I can also from here disable pop-ups. So if you're a Forest Pack user, you regularly get these notifications that you're exceeding some count or other, then you can turn that off if it irritates you. There's also these little groups in the UI now, so you can roll up particular bits of the interface to make it much more manageable. And these persist between sessions, so if you've rolled it up in one session, it will still be rolled up in the next. So that's a quick tour of the UI features. Now we're going to move on to the adding geometry to the items list. So once we've got a Forest Pack set up, we want to add some geometry to our trees, whether they're proxies or XREFs or they're just in the scene. One thing I still see people do quite a lot is to add their trees one at a time. So let's just pick this terrain and add some trees. And then we'll come over to the geometry list and let's look at a quicker way of doing that. So here we have an add multiple button. It lets you pick multiple objects and just click to add them, and it brings them in all at once. That's far, far quicker than doing them one at a time. The disadvantage sometimes of Forest Pack is you've got sort of 8 or 9 trees in here, but it's hard to see exactly which trees are where to sort of plan your scatter. So one option is to turn on Use Color ID in the display rollout. Then what you're using is the color swatch, which you can see next to the names there, to indicate what's being scattered. And it makes it much easier to do what I'm doing here, which is to change the probability of the objects and you can see much more clearly how this affects the distribution of this particular object, like so. Okay, another question we get asked a lot is, can you use groups with Forest Pack? Because it appears as though you can't. And normally the problem people encounter is this: I've got a group here of some table and chairs, and if I pick it, I just get the object that was under the mouse. So you have two options for picking a group. You either use this pick multiple option, and then you pick the group from the list, or you can select the group and open it, which gives you the brackets around it, and then you can pick the brackets instead. And then you get the whole group. And what's interesting about using groups, as you can see here, is that with the transform settings on, like rotation, probably not scale for Forest Pack, every object in the group is getting a random value individually. So each chair in that group is getting a random value. Each table, each item on the table is getting its own random value. Now that can be good and bad. In this case, that's great. That would give us a nice randomized restaurant, for example. But what if we wanted to rotate the whole thing as one? Well, that's another question we get a lot, and there is a workaround for it. First of all, it involves putting the pivot points for the group all in exactly the same place. In this case, I'm just aligning them to the base of the table. So the pivot points for every object in that group is in exactly the same place. Now, we'll come back into Forest Pack, and in the rotation setting, just choose a map, a noise map. And we're going to use that noise map to control the randomization. Now, what happens now is that all those objects, they look at what the pixel value is under their individual pivots. And because all the pivots are in the same place, that means they see exactly the same value. And that way, you can randomize the whole group as though it were one object, even though they're still separate. One important thing to note is you have to turn on translation, otherwise the pivots aren't in exactly the same place. So to use that technique, you need to turn off translation randomization. But that's a really handy trick if you have a need for that kind of thing. So obviously in this scene that we're looking at, there's a lot of surfaces, and it's really important to be able to master using the fall-off controls in order to be able to control exactly how these items are distributed on surfaces. So for example, if I add trees to this background mountain here, you can see they're distributed across the entire terrain, including in the water. We want to be able to control that without having to manually paint those areas out. And the best way to do that is using Falloff Curves. So if we go into the surfaces rollout, here, first of all, we can see there's a direction slider. Now the direction slider moves the trees so they either follow the surface normal, they go all the way straight down, or they look straight up, or somewhere in between. For trees, you generally want straight up or somewhere in between. Now we can limit by altitude range too. So we can stop the trees growing at a set altitude range using this top parameter. We can also do the same for the bottom parameter. So this will get them out of the river. We don't want trees growing in the water. Excuse the notification. There's also fall-offs. So these are curves, and what these let you do is to control that density using a gradual fall-off defined by this curve. So instead of it being a hard on or off, you can just gradually say, well, from this point to here, I want there to be fewer trees, and it gradually gets less dense. You can see it happening in the background over here. You can do the same thing for scale as well. So now you see I've removed them from the river. So we can do the same thing for scale. So as the trees reach to the top of the mountain, they can get smaller using this curve. So the bottom of the mountain is on the left of this graph, top of the mountain is on the right. And maybe they get smaller because there's less oxygen up there, might have smaller trees, might have fewer trees. You can control all of this using these curves. You can do the same thing you can do the same thing using the slope angle of the terrain as well. So if we just wanted to stop the trees being on the cliffs where they really might not get purchased, we can control that using the slope angle. So now we're saying the maximum angle here that a tree can grow on is 60 degrees, for example. Or instead of having a hard cutoff, we can use curves just like we saw before. So you get fewer trees on the steeper angles instead of no trees on the steeper angles. And the same thing with scale. So smaller trees on the steeper angles. Loads of control here to do interesting things. These graphs don't have to be linear, of course. You could get multiple peaks to create kind of several layers of trees as they grow up the mountain, for example, and do other interesting creative effects. So this works great when there's actual geometry in the scene to scatter on. But more frequently these days, people are starting to use displacement for their surfaces. Now, whether that's the whole surface that's displaced from a flat plane or a displacement modifier on top of an existing undulating surface. The problem is that displacement requires the geometry to be rendered or created at render time, and Forest Pack requires the geometry to be created before render time to place the trees. So we need to work around that. One of the ways we can do that is to use one of the new features in Forest Pack 6, which is the ability to create special effects. Effects are small snippets of code, basically, which allow you to extend the features of Forest Pack. It was introduced in Forest Pack 5, but in Forest Pack 6, it got a lot better with the ability to use maps and graphs, as we'll see here. So here's a typical situation, simplified for demonstration purposes. Here I have a plane, and I'm putting a displacement map on here. If I render it, you can see the plane is displaced, but the forest objects which were on it are not. They're still on the ground. So the solution is to use that same displacement map in this new forest effect here. And you can see in forest, this forest effect has a map input, which is a new thing in Forest Pack 6. So I can pop the same displacement map in there so that it knows what the displacement is going to be. And for the displacement amount, I can actually link Forest Pack to the displace modifier on the surface. So I just link Forest Pack to the displace amount and then turn this effect on. Just click out here. And you'll see in the viewport, even though the geometry doesn't exist yet, Forest Pack's able to read what the displacement is going to be based on the amount in the modifier and the map itself, the same map being used. So this is only possible in Forest Pack 6 because we now have the ability to read maps. The other thing we can do in Forest Pack 6 is use multiple effects, which is new. In Forest Pack 5, we can only use one at a time. So we have a second effect here, which is called rotate to normal. We can only approximate this because the geometry doesn't really exist, don't forget. So to get around it, I'm wiring displacement map for a V-Ray bump to normal modifier with local XYZ mode. And then I'm going to wire this to the map input for this effect. And what this should be able to do is to read, once I've changed the angle, is to roughly approximate the angle of that surface once it's been displaced. And for most purposes, this is good enough. So this is two effects. They're both included in Forest Pack 6, so you don't need to create them. And it makes it possible now for you to scatter on a displaced surface. Here's another example of effects. In this example, let's imagine you want to populate a scene, like create a whole ecosystem based on altitude. Instead of just turning objects on and off, we want to create an ecosystem. And we want to do it based on probability. So here, I've got an effect, which I'm going to load, called probability by altitude layers. So it means I can add more than one. What this does is it lets me set a minimum and a maximum altitude for this to take place. And I can choose the parts from the items list that I want to just place on this particular area. And then I use a Falloff curve, a probability curve in this case, to determine the likelihood of that item being selected within that altitude range. And in this way, I can control, you can see the numbers changing on here, I can control the probability of number 1, for example, being selected on the low altitude areas of this terrain. This wasn't previously possible, but with this effect, we've been able to extend Forest Pack and add features that weren't possible. And also, without adding something else to the interface, you load these effects only as and when you need them. The nice thing is too that you can stack these up. So if we wanted to create a different type of planting on top of the mountains, for example, I'd create another probability by altitude, set the settings, and then I can create a different graph. So I'll change my graph here the opposite way around, so I'm getting them just on top of these bumps. You can see I'm getting the darker grey ones on top here. And if I can change the curve, you'll see I'll get more up there. So using this technique, like I say, you can create a probability-based, an altitude-based ecosystem based on a probability of an item being selected using its position on the z-axis, which is pretty cool. So I think probably most people who've used Forest Pack before know that it works based on distribution maps. And distribution maps are these little black and white grayscale maps that are included in the distribution rollout. They work pretty simply. A white dot on one of these is a tree, and a black dot is a space. And the number of objects that can be scattered by an individual map is determined by the resolution of the map. So these maps, for example, are 100 by 100 pixels, which means they can scatter 10,000 trees before they repeat. In Forest Pack 6, we added a bunch more of these due to requests for people to make things from people that we make maps that are a little bit less regular and have patches for clearings and that kind of thing. But we also had a request for probability-based maps. So because it's just a white pixel is a tree, black pixel is no tree system, if we use a gradient like this, rather than it gradually thin out as it reaches the top, there's just a hard cutoff, basically where Forest Pack decides this pixel is no longer white. If instead we want a probability-based system, what we can do is to use an effect. So again, we're extending Forest Pack using an effect. So there's an effect here, which is density map based. And basically we plug in our gradient into this one map slot, that's all it's needed, and turn it on. And now it works exactly the same way as you would imagine. So that white pixels have a high probability of an item being distributed, and dark pixels have 0 or no probability of an item being placed. And it makes it much more intuitive for you to be able to paint distribution and control the density of objects just using grayscale values. Okay, so one of the interesting things about this scene when I got sent it by a poly machine was the sheer amount of grass that was in it and the way they'd scattered the grass. So these were all the ground cover objects that were used in this scene, and we're going to focus just on the grass. When I first looked at it, there were nearly 6.5 million blades of grass being scattered individually in this scene. Now, Polymachine are blessed with very, very powerful computers, and this didn't really worry them too much, but I would recommend a much more optimized approach of creating large areas of grass, which involves basically creating smaller patches first. And it works basically like this. So first of all, I'll create a spline, a circular spline, like you can see on the right here, of could be 50 centimeters to a meter in size. And I'll use this to create a small patch of grass by selecting the various individual grass objects, which we can see on the left from the scene. So I'll just load those and delete the original. Now, we'll change the display mode to points cloud and come up to the distribution rollout and change the density, because there's too far fewer trees, plants in there at the moment, and then just change the density down so there are more grass objects. I'm also going to randomize the transform to hide the fact that some of these grasses are going to be repeated. So I'm going to randomize the translation, rotation, and scale. I'm just going to use the defaults here, I think. Okay, so we've got some grass. Now, one thing that I tend to do with patches now is I thin out the density as it reaches the edge of that grass boundary, of that circular boundary. The reason is they're going to overlap in the final distribution. So I don't want a double sort of thickness of grass where they overlap. By thinning them out like that, I avoid that problem and I get a consistent density of grass once they're next to one another. And that's more or less it. So that's creating a single grass patch. You can create a few variations of this with different probabilities of grass objects and that kind of thing to get an interesting mix that is sufficiently different that it's worth the extra poly count. The other important thing about these patches is, and I see people do this all the time, you don't need to do anything else with them. You can put one Forest Pack object inside another. So there's no need to convert this to an editable poly. There's no need to bake it out in any way. Just leave it as a Forest Pack object. And then once you've done that, we can start to add it to Forest Pack. But an important thing to realize, or important thing to learn about, is edge mode in Forest Pack, which is a distribution technique that lets you use large patches but still get nice clean edges on the more refined areas. So a typical problem when you're using patches is something like this, where you can see along the edge here, because we're creating little discs of grass, they overhang the edge. In Corona particularly, this is a problem because people don't realize that in order to make this mode work in Corona, you have to add a special map to the opacity input. Now, Forest Pack can do this automatically for you using the Optimize Materials button, which you've just seen. And you'll see what you've got now in the opacity input down here is a forest edge map, which still has an existing input for opacity maps if you need them. Once that's done, all you need to do is turn the boundary checker mode into edge just by clicking on that mode. Nothing will happen in the viewport. So again, don't think it's not working. It is, but it's a render time only effect. And you can see now as we transition to the edge mode version, the edges have been really cleaned up. And it's still using big patches, so you've still got all the efficiency of using the large patch, but you've got the clean edges that you would get if you were using individual blades of grass. And a really important thing to realize about edge mode is how it actually works. It's not just slicing the grass, it's not just cutting it off, because if you were creating a bush or something like that, that would be very unnatural. You'd end up with half a bush. What's actually happening is it looks at each individual element within the patch or within the plant, and it looks to see where its lowermost vertex is. If its vertex is inside the area, that piece of geometry is retained. If it's outside the area, the geometry is removed, and this still allows you to have grass that overhangs the edges as it would naturally. So once we've got our patches, we can create the larger areas and optimize them too. So we pick the whole surface and then turn the surface off because we don't want it everywhere. We just want it within inside this spline area. So I'll add another spline area, and this time set it to exclude. So I'm adding splines to add and to take away. And that way I can create interesting sort of patches or clearings inside this grass to add some variation that will look much more interesting from a distance. We've also got a single spline here, which is open. So you can use open splines as include and exclude areas just using a thickness parameter. In the surfaces rollout, we want to limit the altitude range like we saw before to make sure that the grass isn't in the lake. So just by limiting the altitude range there, we can see the grass is no longer in the lake. And I'm just going to open this up so we can see how many objects we have now and see how many objects we get finally. Remember, we had 6.5 million objects being scattered to start with. At the moment, we have 8,000, but we haven't added geometry yet. So here we'll add our patch that we just created. So there's the patch, still a Forest Pack object, note. Now there's obviously too far apart at the moment, so we need to change the distribution. So we'll change to full first of all. That creates the maximum number of objects, but it does create a slight grid-like pattern that we need to get around in a second. But we can see the grid pattern seems to be working okay for the density. Let's just tweak it a little bit. See, that's too much. Bring it in a bit. So they overlap basically on the edges. And that's why we could use that fall-off effect earlier. Great. So we need to remove that regular grid. So to do that, just like we saw with the trees, we'll go to the transform rollout in a second. Transform rollout and turn on rotation, turn on scale, and really importantly for breaking the grid, make sure you turn on translation randomization too. That will shuffle every patch around a little bit, and you won't get this obvious repeating pattern. I'd also turn off X and Y rotation so that the discs don't pop up on end, and also make sure that in the surfaces rollout that the direction is set to normal so that the patches follow the surface. Otherwise, again, on undulating terrain, you'll end up with discs which are kind of stuck up in the air so you can see the edge of them. So that needs to be set to normal as well. So now we've covered our whole area. We're on 35,260 objects. That's still much better than 6.5 million, but we can do better than that. And the way to do that is to go into camera mode, a camera rollout, sorry, and pick the camera from the scene. And then turn on limit to visibility. What happens now is it's only rendering those patches which are visible to the camera. So anything that's behind the camera, anything that's outside the camera's view is no longer being created. That's a huge saving. It's now down to 10,210 objects. But we can do better than that too, because we don't really need that kind of density of objects that distance from the camera. So what we can do is reduce the density of the grass patches the further it gets from the camera. We do that using the distance fall-off settings, controlling the density, and a minimum and a maximum range to define the effect over which this takes place, or the range over which this effect takes place, I should say. The actual effect, or the actual reduction in size, is controlled using a curve, just like we saw with the altitude range earlier. So here, there's an edit curve button. You just pop that open, and it controls the fall-off. By default, it's linear, which is fine. I'm leaving it as it is for now. From the camera's perspective, as you can see, you can't see any difference. But now I've gone from 6.5 million objects to 8,412, which is significantly better, and that's going to speed up your renders and memory usage a lot. Good ground cover is created by stacking up layers of ground cover on top of one another. Trying to do everything in one Forest Pack object isn't often the easiest way to go, and just using a simple grass on its own won't necessarily give you the most realistic results. So in Forest Pack 6, we included, as an example of this, a new library of grasses which work on this principle. Basically, you have a base layer, like a grass like this, that you can create. And these have been improved too, so that they're less continuous. You know, they've got patches of mud and stuff that show through, so they're a little bit more realistic. But that's probably not enough on its own. Instead, what we want to do is to duplicate that. So I've just cloned it, and then we can pick one or more of these other overlays. So we can add plants on top of this. And the nice thing about that is that they can be controlled completely separately. So I can control the distribution of these blue flowers, for example, these blue weeds, completely separately from my grass. So if I want to spread them out further, I can do that. If I want to make them denser, I can do that, or whatever. And you can keep going. So we can add some of these dandelions, for example. And again, I've got complete control over this as a separate layer. I can control the dandelions separately from my blue plants. I can control the whole lot completely independently to get much nicer ground cover. And this Studio Niscota guys, Poly Machine guys, used this to great effect, and in fact, they created a lot of layers in this scene to add to the realism. So here we can see the build up. Here, for example, we had the long grass that they created, and you can see it's down here, these long grass, patches of grass here. They also added rocks, dead leaves, lily pads in the pond, sticks and branches, reeds, more reeds, lots of individual grass tufts. There are a lot of mushrooms in this scene. They've got a problem with damp here, I think. More grass tufts, a ton of trees. And then finally, here you can see the spline areas that were used to place all of these. Now that looks like a spider's web of splines, but really once you understand the principle, it's pretty straightforward. And a lot of them were painted using the painting tools. Another neat trick is the ability to scatter around the perimeter of other things. So here, for example, we have the boardwalk in the scene. We've got a couple of problems there. The grass is already going through the boardwalk. You can see it's coming through the surface. But specifically what we want to do is to go just around the edge of it. So we'll turn off the surface, and we can add that spline in as an include area. If I increase the thickness of that spline, you can see the grass grows out from the boardwalk a set distance. But it's going through the boardwalk. So how do I remove it from the middle of the boardwalk? Well, you could use curves, but there are a couple of other options. So what I can do instead is to add the same spline a second time, but this time set it to an exclude area. So I'm using the first spline to add it and the second spline to take it away. And in that way, I can clear it from just under the boardwalk, all using the same spline. You can also use fall off again. So instead of it being a fixed density, I can make the density fall off the further it is from the boardwalk, as it might do naturally. And you can change the scale using the same technique. You see, as I say, this is a Forest Pack board, a RailClone boardwalk, so everything is adjustable using the same spline, the grass and the boardwalk. Sometimes, though, you want to be more precise than that, and that's where you can use paint areas. So what paint areas let you do is to basically paint splines in behind the scenes. That's what's happening, but you're painting spline areas using Forest's built-in paintbrush tools. So let's pick some weeds as an example. So here they're applied to the whole surface, but I'll turn the surface off. There's a little paintbrush icon here, which lets me add a paint area. If you come down, here you've got some brush settings. And you can see that I can control the maximum size of my brush here. So this is how you change the size of your brush. Actually, unless you're using a tablet, you can ignore the minimum size. And now you just click to paint. Very straightforward. I'm clicking and painting. The nice thing about creating a spline area like this is that you can use all of the parametric tools to change the distribution after the fact, as we'll see in a second. You're not stuck with one paint area. You can use multiple. So I can add stacks of these, one on top of the other, and create multiple spline areas, painted spline areas, and get them just where I want them. You can also add paint areas as subtractive areas, exclude areas. So as well as painting to add things, I can add one of these to take away. So I'm adding a separate paint area to remove things. But also you can just use the eraser tool. So I can just click on this just to remove the paint area that I've already created. Like so. The really interesting thing about areas in Forest Pack, and a little used feature, is the fact that you can actually customize each area separately. So for example, if in one of these areas I only wanted a sub-selection of the models that are available to me, you can easily do that just by clicking on this option here. And I could, for example, just choose the purpley kind of plants and add them to this paint area. And now you can see I've just got those ones in that paint area. And that's not just paint areas that support this, that's every other area in Forest Pack. So for this one, for example, I could go for the bluey ones. So now I've got two areas. Each one is controlled. Each one is painting a different type of plant. And you could overlap them too. You could paint one on top of the other, like so. Here we go. But it's not just types of plant you can control per area. You can control the distribution as well per area. Again, a little known feature of Forest Pack. But I can control the scale of the distribution maps being used just on the area that's distributing the blue plants. Here, for example. I could do the same for the pink plants separately. I can control the threshold, for example, here too, which is the point at which a pixel is considered to be white and creates a plant. Or maybe I want a completely different pattern instead. So here I've got a different distribution map, one of the new ones. If I drag this into this distribution map, it's applying a completely different distribution map just for this one paint area, not affecting the pinky purple plants, but just the blue ones. Gives you a tremendous amount of control over each individual piece of this composition. Another thing here, say I want to move this boat in here. I'm not sure where I really want it to end up. Well, it would be a pain to paint that boat out every single time that I move it. So instead, you can add objects to your distribution. So I can add this object here, this boat, as an exclude area. It's exclude by default. You control the resolution to increase the improve the collision accuracy, and you can scale the collision up too to make sure it's just slightly either side of the boat. And now you see as I move this boat around, it's excluding parametrically and dynamically. So I can make changes to this scene really easily without having to repaint anything. So new to Forest Pack 6 as well is the ability to scatter along splines. Here we've got lights that we want to scatter along these splines on the boardwalk. And skip ahead a bit. Here's new path mode. So this new path mode is what makes that possible. You just basically pick a spline from the scene and you can change the spacing between objects. It's like a little bit of RailClone in Forest Pack. I've got control for offsets, or I can put them on vertex positions. You can use multiple paths. There was something similar in Forest Pack previous to 6, but it wasn't parametric. Now, if you change the spline, if I change the spacing at any point, the whole thing updates, no problem. And you can still use rotate, scale, and transform variation if you want to. You can choose to follow the path, or you can choose to just randomize it. The question we get asked a lot too is, well, can you scatter lights? And the simple answer to that is no, not really, not technically possible, but you can use a script to scatter lights. So there is a script available on our forum which will allow you to do this. Let me just jump forward a little bit to the relevant section. I've used the manual way. Okay. So I apologize. This video is a little out of date. You can turn lights into instances, and then you can distribute the lights on the instances using Max's native tools. That's the way this video shows. I wouldn't use that. I'd use the script that's on the forum, which does it in just a click. So by all means, ask me about that in the questions afterwards. Finally, then, coming up to the end, once you've distributed everything parametrically, sometimes you want to take control of the scatter manually and just move those last few trees that aren't quite where you want them to be. And that's what item editor mode does. It lets you convert any scatter into manually placed items, still inside of Forest Pack objects, still with all the advantages of using Forest Pack in terms of memory usage and that kind of thing. But now you can select individual items and you can move them around. So here, for example, I can just pick up these trees and I can start moving them to exactly where I want them, or you can delete them, or you can rotate them, or you can transform them. I can also change the items so they're different. So if you had two trees next to each other that look too similar, for example, you could change them to a different model. You can randomize the selection, and you can reseed the selection too if you want to re-randomize the transforms. Something else you can do is to use reference mode. So instead of placing them manually like that, often we'll get models from architects which have markers where they want trees very specifically, or other items. And Forest Pack now has the ability as a new distribution mode to use references. So the way this works is you just pick a reference from the scene, or you pick a bunch of references from the scene using the multi-object, and it puts an item on each pivot point in this case. Or you can use face centers if you prefer. You can match the alignment and the scale of those objects if they've been scaled. And much more interestingly, in Forest Pack 6, these are live linked. So if I move this object around, this original marker around, I'm moving the individual tree, which is a little bit about like the tree editor mode, but this time it's linked to a specific marker instead. You can also animate those markers too if you need to. It opens up a whole load of new possibilities and ways of using Forest Pack. Another new mode in Forest Pack 6 is the ability to use PFlow objects and scatter on PFlow objects. So here in this scene, we had the lanterns in the foreground, and to create those going up through the scene, we can use a PFlow. So we can see here's where we want the lanterns on these particles. The nice thing about scattering on particles is that motion blur is fully supported. So here in PFlow mode, we just pick the particles from the scene, and well, actually that's it. There's nothing more to it. It places an item on every single particle, and it can match the alignment and scale of those particles. Once again, this opens up Forest Pack to whole new uses and workflows. You can also use it in conjunction with the animation randomization feature, so you can control it with particles and then randomize the animation separately. And with Forest Effects, of course, we have access to various attributes of these particles, like the ability to change any attribute based on the particle age. In this case, I was changing the color of those lanterns based on their age, so they got duller the higher they got. And that brings me neatly to the end. I think I've got 1 minute and 25 seconds left. But that's a very quick tour of the creation of this scene, showing you some of Forest Pack 6's features along the way. I'd be interested to hear if you've got any questions. There is a more detailed description of this scene on our website as well, if you'd like to read more.
Great job, Paul. That was
No worries.
excellent. We have one question.
Yes, good.
Jason asks, I've never used Corona, and we want to know if the amazing soft shadow thumbnail in the material viewport in 3ds Max is due to the Corona MTL, or is it part of setting in 3ds Max settings?
That's a Corona question.
Uh,
Yeah, to my knowledge, that's a Corona thing.
okay.
Yeah, I think it's something they've done. I'm not 100% how they've done it because I'm not a renderer guy. But yeah, it's I've never seen it in any other renderer.
Okay. I hope that
I'm not
answer.
Yeah, sorry.
No problem. So no, we have no other question, but we can wait a couple of minutes. And
Sure
you've
thing.
done a great job answering a lot of questions as you went, because you know the questions that are more common, and I'm glad you did try to clarify those. And I think yeah, so we'll wait a few more minutes. In the
Sure thing.
meantime, you know what I'm going to do? Yeah, the feedback is no, we have no other question because it was so thorough, and
Well, there you
that
go.
was my point exactly. So we're really grateful for that. I'm
Cool.
taking my screen back, if that's okay.
Yeah, the only thing I was going to quickly
Yes.
show was, I know I haven't got long,
No, go ahead.
is the Forest Pack Pro. Show my screen. Script this. Okay, so we have a few script mentioned scattering lights on forest objects because it's a really common request. On our forum, if you go to scripts for Forest Pack, you need to be signed in with a pro account. But there are a number of useful scripts in here which you can use to do all sorts of things that aren't built into Forest Pack. So, like for example, if you've been sent a scene which has instances in it already, like thousands of instances, and it would be easier if those were in a Forest Pack object, then this script instances to Forest will help you. But the one that I find particularly useful is the lights instance object. And basically what that lets you do is to select your light, select a Forest Pack, and it will just, it's very simple. It just puts a light or any other non-geometric object actually on each instance inside Forest Pack, and it matches the rotation and the scale. So this is the technique I would now use in order to scatter lights with Forest Pack until we support it in some other way. And there's a little video on how to use it too. So that's all I wanted to just add.
Great. So somebody is asking if they can watch the webinar later, and I was about to write, but I can say now that the recording will be posted on our YouTube and Vimeo channels. Just search for Novedge. It'll take me a couple of hours, and you can watch it over and over again. And now I'll take the screen back. Just a couple of seconds, and I want to thank everybody for attending. And this is where I remind you where to find Forest Pack 6 on the Novedge website, novedge.com. We have Forest Pack, we have RailClone, and a very interesting bundle with both of them. And as Paul announced, we're going to have another webinar in the near future with RailClone, so stay tuned for a webinar announcement. Thanks for joining us today. So, you know, if you follow us on Facebook and all the social media, you'll know what's coming in our next webinar. Next week is Vectorworks 2019. Thanks again for joining us today, and have a great rest of the day. Bye-bye, everybody.